Hi everyone. Today we are going to start alternating current. So let us start with just the introduction. So what is alternating current? Now alternating current, if we see, this is a current which changes the direction. Now what do we mean when current changes the direction? Eventually when we talk about current, what is current? Current is the flow of electrons, and when these electrons moves in a direction, okay, so we have already seen in current electricity that electrons flows from positive terminal of the battery towards the, electrons flows from negative terminal of the battery towards the positive terminal of the battery. So that's the direction. But what will happen if this direction is continuously changing? Then electron will simply vibrate, and that's what our alternating current is. In alternating current, the direction of current is going to change periodically. When we say periodically, means after a certain time direction is changing. Okay, direction is basically changing both ways, and with a certain period it's repeating. So that's what it means to be periodically. Now if we talk about direct current, now this is a alternating current. If you see any particular electron, so this particular electron is simply vibrating. So this is the symbol for an AC source, and this is a symbol for an AC source, and these are all the electrons, and they are just vibrating. If you see any of the electron, it is never leaving its place from its original position. It's just vibrating, and that's what this type of current is called, alternating current. Here this is a typical graph of the alternating current, and this here we say that the direction, if this is with time and this is the magnitude, here for this particular half cycle the magnitude is positive, but again then magnitude is negative. So here we'll say magnitude is less, then it is more, then it is maximum. So magnitude is changing, but at the same time, and it was positive for first half cycle, it was positive, but for next half cycle the magnitude is negative. So negative magnitude implies that direction is exactly opposite to this particular cycle, and the magnitude is again lesser negative, more negative. So magnitude is also changing and direction has already changed. So here only the magnitude was changing in this cycle, and if we compare between those adjacent cycles, then we'll say here the direction is also changing. Now next is our direct current. So direct current is simply written as DC, and it is if a current maintains its direction, and then it is known as DC. So this is a typical DC which is flowing from a cell. This is a dry cell or a battery, and if you see the electrons, they are continuously moving right throughout the circuit. If you check the direction of any particular electron, it's never changing, and here the electrons are not stationary, they will be flowing throughout our circuit, and that velocity is known as drift velocity, which we discussed in current electricity. Here if this is a typical graph of a direct current, so here the magnitude is kept as constant, and if you see magnitude is always positive, but this is just one type of direct current. If we say that this current will be counted as direct current or alternating current, the answer is going to be, here the magnitude is positive, then more positive, then again more positive, lesser positive, zero, and then again positive. So it was whether positive or zero. So we'll say either it is moving in this direction or stationary, again moving in this direction or stationary. So we say such type of current also comes under DC, where it is either always positive or always negative with a varying magnitude or a constant magnitude. That is called a direct current. In alternating current, the direction changes, or we can say in the graph with time the magnitude of current changes the sign. Sometimes it is positive, sometimes it is negative, and that is what our AC is. So let us discuss the AC in more detail. So first is waveform. So this is how alternating current voltage or graph looks like. So this is a typical sine wave. Okay, and sine wave, alternating current or alternating voltage. It is alternating voltage which produces alternating current. So both have similar sine wave form, and here this is the sine wave form which is most easy to study. Why are we not reading other alternating forms? Because they are hard to study, they are not standard. So standard is sine waveform, and here in the sine waveform, if we start talking about the points, the first point is the time period. We'll say the time interval between a definite values of two successive cycles. Basically I am taking, this is my one cycle, I'm taking, let's say this is a fixed value. Again, the same value in the next cycle we are getting here. And this gap, this duration is my time on the time axis. So this is the time period. Similarly, we can also say from here, like starting 0, and in the next one is starting 0. So this gap is also the time period. So this is how we define the time period. Next is the number of cycles or number of periods per second is your frequency. So frequency is reciprocal of time period. Then the maximum value, here the maximum value of either, if we are making the voltage graph, then it is maximum value of voltage. If we are making a time graph, then it is maximum value of time. Now that maximum value is called the amplitude. Okay, so here V0 or I0 is called the amplitude. Now if we talk about, let us say that this function is a sine function, okay, and it varies like this. So the current at any time is I0. I0 is maximum current, also known as peak current, sine omega t plus phi. So if this is the form, then this is called that it is a sine varying function. So generally we are going to study our sine varying function. Our current, our alternating voltage, they are going to be sine varying function. And in these, okay, so here I0 is known as peak current or maximum current, which is nothing but amplitude on the graph. And what about the entire angle? This angle omega t plus phi, we are going to discuss this in detail. So this angle is known as phase. So what is our phase? Omega t plus phi. The entire angle inside the sine is known as phase, or we can also sometimes call it phase angle. So this represents the phase. And omega, in this phase, the omega is known as angular frequency. Okay, and what about the unit? Unit of angular frequency is radian per second. How angular frequency is related to the normal frequency? So omega is nothing but 2 pi times normal frequency, and SI unit of normal frequency is per second or hertz. And reciprocal of frequency, that is nothing but our time period. So time period and frequency, they are related like this. These all are just coming from waves. Okay, so we have already discussed all these in details in the wave. Here we are just revising it. The next thing we are going to discuss is some values or some important things about the alternating currents. First is peak value. We have already discussed the peak value is the maximum value, or the, we can say, amplitude of the graph is called the peak value. Peak value is generally written as V0 and I0. Next is the mean square value, right? So mean square is, first we do the square and then we find the mean. That's what our mean square value is going to be. So the average of squares of instantaneous values in one complete cycle is called the mean square value. It is always going to be positive because first we are squaring all the values. So if we make the graph, then our graph is like this. This is a typical sine graph, and here we can have a current or we can have a voltage value, and here we have time. So if you see the values of current, let's say just talk about the current. So current is positive, current can be negative also. So if we find the overall average, then it is some positive value, some negative value, and that's how we find the average. But here we are squaring first and then finding the average. So when you square all the things, each and every unit, like quantity of or value of current will become positive. Whether it is negative, once you square it, it will become positive, and then you find the average. So average is always going to be positive. It is never negative, right? So whether you take full cycle or half cycle. Now this is how it is given. So this is a formula for finding the average. So how do we find the average? If there is any value y, okay, and you want to find the average of that particular quantity, then mathematical expression for average is this: integration y dt over integration dt, and here we put the times as a limit. Okay, so this is basically the average of y. This is how we find, and limit, if we want full time period, then we put full time period. If you want half time period, then you put 0 to t by 2. This is how we find the average of any particular quantity. Let us see how this is coming. So here the quantity is my voltage. I want to get the mean square value for the voltage. So instead of y, I am going to put my v. So it is going to be integration. Instead of y, I have v. But I want what? Mean of square. So I want, what is my y? Here I am finding the average of y. I am finding here mean of square values of v. So that is v square will be replaced with the y, and then it is dt, and I want full time period, so 0 to t, and divide by integration dt and 0 to t. So this is going to become t, right? Capital T. So that is 1 by t integration 0 to t v square dt. And now we simply put the value of v. What is our v? V is a sine function, right? We just discussed that it is going to be sine function. So we will just write v as v naught sine omega t plus phi, or we can simply put v naught sine omega t. I'm not taking phi as of now. We'll later discuss what phi is. So it is integration of v naught. Now v naught is a constant. It will come outside. It is square of that. So square sine square omega t and dt, and divide by simply t, and here limit is 0 to t. When you do that, you get that this value comes to be half. Okay. And what is capital T? Capital T is 2 pi by omega. Omega is a constant, and t and omega are related by 2 pi by omega. Once we finish that, we will get that v naught square by 2. Similarly, if we are writing for I, then we not I naught square by 2. So that's our mean square value. Okay. In same manner, we can also go for root mean square value. So it is just mean square value we find first, then we find the root. So that is called the RMS value or root mean square value. So root mean square value is nothing but it is the root of all the mean square value, and in simple terms or in short it is called RMS values. Now if we talk about RMS values, so VRMS is all just going to be the average of all the V square values. Here the values of V, they are going to be continuous values, right? So instead of summation, we use integration. So this is, if you see this parameter properly, this is nothing but average value of V square. This is the mean square value, and then I am doing a root. So I will get the RMS value, and we already did that. It comes to be V naught square by 2. So, and then we do the root. So root of V naught square is simply V naught, and root of 2 is simply root 2. So this comes to be V naught by root 2, and here it is basically 1 by root 2 times V naught. What is 1 by root 2? 1 by root 2 is comes to be 0.707. You need to remember this, as sometimes like this is useful a lot of times. So we'll be saying that how much VRMS is 0.707 times V naught, and 0.707 is how much? Roughly 70.7% of V naught. So in terms of percentage, we say this. So this is the how RMS value and peak value are related. So again, just going for current. So again, voltage and current, they have the same sign function. Okay, so they will be related like RMS. IRMS is I naught by root 2, and that comes to be again 0.707 I naught. That is 70.7% of I naught. And here we are giving a generalized formula that root mean square, see, RMS value or root mean square value is always peak value of the quantity, that can be current or voltage, divided by root 2, or we can also say 0.707 times the peak quantity. Now next is the mean or average value. So this is directly finding the average. So when we directly find the average, so AC voltage or currents, they are basically common, generally sine waves. Okay, they have sine or cosine functions, and their mean values for complete cycle will come to be 0. Why it is coming to be 0? So here we are saying that average value for full cycles, they are 0. Reason is simple. Whatever is the positive value, same negative value you will get. If there is a positive value, you will get negative value in the next cycle. So when you find the average of this value and this value, that is 0. Similarly, the average of this value and this value is 0. So there is always one quantity which cancels or which added and gives you 0. So in the next cycle, corresponding to the first half cycle. So full cycle, it is always 0. So that's why we find the average for only first half cycle. So let us do that. So how much it is for first half cycle? How much it is? So I am saying that it is, let us just say this function is I is equal to I naught sine omega t. This is my function. Let us find the average. How do we find the average of this? I am finding average for just half cycle, okay? So for half cycle, not the full cycle. Full cycle we already know it will be coming to be 0. So average is integration y dt, and y is this I. So I will be writing integration I dt divide by integration dt, and limit I am going to put 0 to t by 2, just half cycle. When you do this, this integration will become 1 by t by 2. So this is 2 by time period. And what about this? This is I naught sine omega t. So I naught is a constant. It will remain as it is in the process of integration. And then it is this thing, integration dt. So what is the integration of sine? It is minus cos, right? So integration is minus cos omega t divided by omega. The coefficient of t also has to be divided. We are doing the integration. And limit is going to be 0 to t by 2. Now, here I am putting the values. So this is, t is what? 2 pi by omega. So instead of t, I am writing 2 pi by omega. This omega and this omega cancels out. 2 cancels out to get I naught by pi. What about this? I am putting first t by 2. So minus cos and t by 2. Omega into t by 2. T by 2 is 2 pi by omega. So it is pi by omega. Minus of minus cos, and then I am putting 0. So cos 0. Now this value is simply cos pi. Cos pi is minus 1. So this is minus of minus 1, which is positive 1. And then plus cos 0, which is again positive 1. So this entire thing is 2. So the answer is going to be 2 I naught by pi. Okay, so when we say that for first half cycle, if we are finding the average value, then the average value for one half cycle comes to be 2 I naught by pi. We just derived this expression, and now if we say 2 by pi, it comes to be 0.637. Okay, so this is 0.637 times I naught. You need to remember this one. 2 I naught by pi, okay? So, or we can say in terms of percentage, it is 63.7% of the I naught. And same thing can be done for voltage as well. So, average voltage for first half cycle only, positive half cycle, is going to be 2 V naught by pi. What about they are asking for negative half cycle? If they are asking for negative half cycle, then we will say it is minus 2 V naught by pi, because values are equal, but just the sign is the other way around, right? So answer is just going to be negative. That's the only difference which we will get. So if we want to get for negative half cycle, we can do minus 2 V naught by pi. For positive, it is positive 2 V naught by pi. Now this value, the average value for half cycle, is also known as rectified average value, because full average is anyway 0. So we generally don't use the never full value for the alternating current or alternating voltage. Rather than that, we use RMS values. So the whole purpose of using RMS values is because the average for full cycle is anyway 0. So we are going to use the RMS or mean square values. Now here are some average values for some periodic mathematical functions. So like sine, cosine. So these average, each and every time we are not going to do the integration. This process is simply lengthy, right? So we will say that the average of sine theta is basically 0 for full cycle, always for full cycle, okay? And the average value for sine theta, when I am saying sine theta, that theta can be omega t and we are doing time average. That theta can be kx and we are doing x average or average with respect to x. So it can be anything. But if it is a sine function and then we are doing for half cycle, it is 2 by pi. We just derived this expression. And next is similarly, the average of cos theta for full cycle is 0 and for half cycle it is same, because we know that the graph form is same, right? So again, cos, this is important thing. As we all know that cosine graph looks something like that. So when I am finding average for this half cycle, it is going to be 0. So here for cos also, the 2 by pi is basically for which half cycle? From here till here it is 2 by pi. So you need to be careful in cosine function. When you are writing a cosine function, it is this half cycle, it is 0. For this half or this half, it is basically 0 and 0. For this half cycle, it is 2 by pi. So you need to be careful in when using cosine function which half cycle you are taking. Now next is the sine square. So the average of sine square or cosine square for a complete cycle comes to be half. And the last thing is the average of any constant value is the same constant. Let us utilize these. So just finding the average value of current. So I is what? I is I naught sine omega t. So if I is I naught sine omega t, then let us find the average of current. Now I am finding for full cycle. So I'll say average of current is nothing but average of this quantity. Now average of this quantity is average of I naught and then average of sine omega t. Now we'll be saying that average of I naught. What is I naught? I naught is the peak value of current, that is a constant, and average of that is going to be 0 because we have discussed that average of that is going to be same. Average of any constant is same. So average of I naught is nothing but I naught only times. What about average of sine omega t? So this is a sine function. We are talking about full cycle. So I will be using 0. Average is 0. So use 0. Now that comes to be 0. So this is how we can do. Similarly, what about the square, mean of square? So I am finding mean square value. So if they are saying that get the square and then do the mean, then I'll be saying that square is nothing but I naught square sine square omega t and the mean of that. Then I will be saying that this is I naught square ka mean times the mean of sine square omega t. So we have seen that for full cycle, this is I naught square is again a constant and mean of that is simply going to be I naught square, same constant. And what about the mean of sine square? So we have discussed that sine square will have a mean of half for full cycle and eventually this is half. So the mean square value of the current is I naught square by 2. And if they are asking RMS, that is root of mean square. So root of this is I naught upon root 2. So this is how we find the average values for different functions. Now next there is a question. This question is saying that find the average value of the current which is shown in the graph. So from t is equal to 0 to t is equal to 2 seconds. Here I am going to use a graphical method, and in that graphical method again, if they have given us y is the value for which I have to get the mean versus time. So I am finding time mean. So it is this. What is integration y dt? It is eventually if y is on y-axis, that can be any quantity. So this is my y dx, like this is my dt. So this is my x-axis. This is integration y dx. That is nothing but area. And limit is, they are saying 0 to 2. So time limit is 0 to 2. So area is starting from between the curve, the time axis. Area is between the curve, which is my y. The time axis, t is equal to 0 and t is equal to 2. So this represent this area. And instead of y, I can simply write my time current, because there is current on the y-axis. So this is my current. Current is varying. As you can see, current is not a constant. And this is the average current. Now, this represents the area of I versus t graph. So what is my area? Area from t is equal to 0 between the curve and the time axis is this area. So that is nothing but half. It is a triangle base into height and divide by. What about integration dt? So integration dt is simply t. 0 to 2 is 2 minus 0. So that will be 2. And then this 2 gets cancelled and we say the average is coming to be 5. Now weren't we expecting this? See, if value is continuously increasing from 0 to 10, in that duration the average can be written. If there is a linear increase, then the average is always the mid value. Similarly, for linear decrease also the average is the mid value. So for 0 to 1 second, the average is basically 5 ampere. From 1 to 2 second, again average is 5 ampere. And eventually we can say for the whole duration the average is 5 ampere. This is the next question. Question says that current in an AC circuit is given by I is equal to 2 root 2 sine pi t plus pi by 4. And now they are saying what is the average value of the current during t is equal to 0 to t is equal to 1. Here we need to do the integration. Or see, t is equal to 0 to 1. Here it is important thing that we find the time period first. So let us just have a look that the value of current which is given to us, it is 2 root 2 sine of pi t plus pi by 4. Just comparing it to my standard equation, this is nothing but I is equal to I naught sine omega t plus phi. So I will be saying my omega is nothing but pi, right? So omega is nothing but pi. And now let us find the time period. Time period is how much? 2 pi by omega. And omega is pi, so eventually 2 pi by pi, and that is coming to be 2. So time period is how much? Time period is 2 seconds. And if time period is 2 seconds, then this is a sine function starting from 0. 1 second, it is not starting from 0. So they are asking basically for half cycle we need the average value. But can we use 2 by pi? Answer is no, we cannot use. Why we cannot use? Because that is only for this type of function. But if you see in this, if you put t is equal to 0, then you get sine pi by 4, sine 45 degree, 1 by root 2. So it is starting somewhere from here, from the top, right? Not from there. So the average value for half cycle is going to be different. Now what I am going to do is, I am going to apply the formula because we cannot, this is not a standard case, we need to understand. Even though 0 to t is equal to 1 is half time period, but we cannot say the value of 2 I naught by pi. Reason is simple, because this is not starting from 0. So let us apply the standard formula. It is integration I dt upon integration dt. That's the average value. And 0 to 1. The time limit is 0 to 1. So eventually this comes to be just integration t. So 1 minus 0. And here in the numerator we will get the integration of this. So 2 root 2 is same. This is a constant. Integration of sine theta is cos theta minus cos theta. So minus cos pi t plus pi by 4 divide by pi. So this is the integration, limit is 0 to 1. Let's just put the values and solve it. So this is 1, this is pi. So I'm just writing 2 root 2 upon pi. And then I'm inserting 1 over here. So we get pi plus pi by 4. That is cos of pi plus theta is minus cos theta. So this will give me minus of minus cos pi by 4. Minus of this minus, so plus. And I'll put 0, so I'll get plus cos pi by 4. How much is cos pi by 4? That is 1 by root 2 plus 1 by root 2. 2 by root 2 we are getting. So this is 2 by root 2. Root 2 will cancel out. And we'll get 4 by pi ampere. So that's the average current for this duration.